All right, let's talk about a tool that has completely revolutionized how we build and ship software, Docker. We're going to break down what it is and why it's become such a cornerstone of modern development. Ah, the classic. But it works on my machine. If you're in tech, you've heard this, you've probably said this. It's that universal scream of frustration, right? When your code works perfectly for you, but the moment someone else tries to run it, boom, it all falls apart. Well, that exact headache is the reason Docker even exists. So let's really dig into this works on my machine problem. Because, it's not just a funny phrase. For a long, long time, it was a major roadblock in development. We're talking endless delays, mystery bugs, and just so much frustration for teams who just wanted their stuff to work reliably. So where did all this chaos come from? Well, everywhere, really. You'd have one project needing one version of a tool, and another project on the same computer needing a totally different version. Bam, conflict. Or the classic, the developer's shiny Mac has a slightly different setup than the boring old Linux server in production. And don't even get me started on the setup instructions. They were like these epic novels that were super easy to mess up. It was just a complete mess, a total recipe for disaster and wasted hours. Okay, so how on earth do you solve a problem that big? Well, that's where Docker comes in. And honestly, the best way to think about it is with a really simple analogy. Think of Docker as a shipping container, but instead of shipping furniture or electronics, it ships your code. You know how a physical container protects its contents and can be loaded onto any truck, any ship, any train? Docker does the exact same thing for your software. It guarantees it'll run the same no matter where you... Okay, so let's get a tiny bit more formal, but just for a second. What is Docker really? It's what we call a containerization platform. That's a fancy way of saying it lets you wrap up your application, and I mean everything it needs to run, all the libraries, the settings, the dependencies, into one neat little package. This package is called a container. It's totally self-contained. And the result of all this? It's the holy grail, a consistent environment, absolutely everywhere. By bundling it all up, Docker makes a simple promise. If it runs in a container on your machine, it's going to run the exact same way on your coworker's machine, on the test server, and even in production out in the cloud. Finally, consistency. Okay, right about now, a little alarm bell might be going off in your head. You might be thinking, hang on, isn't this just a virtual machine? And that is a fantastic question. It's probably the #1 point of confusion, so let's clear it up right now and compare the two. The big difference here boils down to one word: efficiency. Look at the virtual machine on the right. To run an app, it has to boot up an entire guest operating system. Think about it, a whole new Windows or Linux just for one app. That's super slow and eats up a ton of memory and CPU. Now look at the Docker container on the left. It's way leaner. Instead of a whole new OS, it just shares the operating system kernel of the computer it's running on. This makes it incredibly lightweight and lightning fast. We're talking about starting up in seconds, not waiting minutes for a whole OS to boot. So how does Docker actually work its magic? Let's pop the hood and take a look at its core toolkit. Everything in the Docker world starts with something called a Docker image. The best way to think of this is as the blueprint. It's a static, unchangeable template that has everything needed to create your environment. All the instructions, all the files, everything. It's the recipe. You could have an image for a web server, an image for a database, or most importantly, an image for your own app. So if the image is the blueprint, then the Docker container is, well, it's the actual house you built from that blueprint. A container is the live running thing. It's your application, up and running, living in its own little isolated world. And just like you can build many houses from one blueprint, you can run many containers from a single image. You can start them, stop them, and get rid of them whenever you want. So how does one of these containers actually come to life? It's a pretty straightforward process. First, the developer writes their code, and they also create a special instruction file called a Dockerfile. Then, they hop onto their command line and basically tell the Docker engine, this background process called the daemon, hey, build me an image from these instructions. The daemon does its thing, and once that image is built, you can tell the daemon, okay, now run it. And poof, you've got a live container. Okay, that Docker file I just mentioned, that's kind of the secret sauce to the whole thing. It's nothing fancy, really. It's just a plain old text file. But inside that file are the step-by-step instructions for how to build your image. It's the literal recipe that Docker follows to the letter. And trust me, it's not as scary as it might sound. A Docker file is really just a list of simple commands. You start with from, which says, hey, let's start with this basic setup, like a version of Python. Then you use copy to say, okay, grab my code and put it inside. After that, you run some commands, like installing all the dependencies your code needs. And finally, you have CMD, which is the grand finale. It tells Docker what command to run to actually start your application. It's a fully automated step-by-step guide to building your environment. Okay, so we've covered the nuts and bolts, but now for the big question. So what? Why does this idea of putting code in a box, why does it change everything? Because this isn't just a neat trick. Docker is the foundation of so much of modern tech. You hear about microservices? Docker makes them possible. You want those smooth, automated build and test pipelines, what we call CI/CD? Docker's the key. It guarantees every single developer on a team is working in the exact same environment, which kills a whole class of bugs. And if you want to run your app on AWS or Azure or Google Cloud, well, Docker is pretty much non-negotiable. So if you take away just one thing, let it be this. Docker creates a standard. It's a universal language for how we build, ship, and run software. It gets rid of all the, well, it depends on excuses. It brings order to the chaos and standardizes the entire process, all the way from a developer's laptop to a massive cloud deployment. And that brings us to the end. What Docker really does is remove the friction. It clears the path between having a great idea and actually getting that idea out into the world for people to use. It gives you a powerful, reliable, and repeatable way to ship your creations. So it leaves us with just one question for you. What will you build and ship next?